Hello, this is Nahyun Kim. Today, I want to talk about why I love physics. And to do that, I want to start with a cat, Schrödinger's cat. At first, the idea sounded impossible, almost like a joke or a story from a science fiction novel. How could a cat be both alive and dead at the same time? I remember sitting there trying to picture it in my mind, feeling both puzzled and curious. When I first heard about this thought experiment, I was confused, then fascinated, and finally completely hooked on physics. The more I thought about it, the more I realized that this simple, strange idea reveals something deep about the universe. That reality is far more mysterious and surprising than we usually imagine. It felt like I had just uncovered a secret hidden deep within the universe, as if someone had quietly handed me a key to a locked door that no one else had noticed. It was as though the universe was whispering its mysteries directly to me, inviting me to look closer and discover more. Physics, to me, is more than just a school subject. It is the language that explains everything, from the tiniest subatomic particles to the vastest galaxies. Physics, to me, is more than just a school subject. It is the language that explains everything, from the tiniest subatomic particles to the vastest galaxies, from the sound of my own voice to the radiation from distant stars. Schrödinger's cat perfectly illustrates how physics can be mysterious, beautiful, and mind-bending all at once. It is playful and paradoxical, but it also raises deep questions about reality, observation, and our role in the universe. Ever since I was a child, I've been endlessly curious about how things work, constantly asking questions that sometimes even adults around me couldn't answer. I remember staring at the sky, wondering why it turned pink and orange at sunset, almost like the world was painting itself for me. I used to play with magnets, pulling them apart and pushing them together, amazed that something invisible could make them move. I even wondered why ice floated while stones sank, and why rainbows appeared after the rain. These small moments built up into a bigger desire to understand the hidden rules behind everything I saw. Physics was the first subject that gave me the tools to answer these questions systematically. Physics was the first subject that gave me the tools to answer these questions systematically. But when I learned about Schrödinger's cat, I realized that physics wasn't just about answering questions. It was about asking even deeper, almost philosophical questions. It made me think about the very nature of reality itself, and how much of what we see depends on our observation. So, what is Schrödinger's cat? Imagine a closed box. Inside, there is a cat, a tiny piece of radioactive material, a Geiger counter, a vial of poison, and a small hammer. If the radioactive atom decays, the Geiger counter detects it, triggers the hammer, and releases poison that kills the cat. If the atom does not decay, the cat remains alive. The strange part is that radioactive decay is random. We cannot predict exactly when it will happen, only its probability. According to quantum mechanics, until we measure the atom, it exists in a superposition, both decayed and not decayed at the same time. That means, until we open the box, the cat is both alive and dead simultaneously. This is called superposition. Imagine a cat that is alive and dead at the same time, waiting for someone to observe it. It sounds impossible, but this is exactly how quantum particles behave at microscopic scales. Schrödinger proposed this thought experiment in 1935, not to frighten anyone, but to demonstrate the strangeness of quantum mechanics. He wanted people to see how bizarre it would be if quantum rules applied to everyday objects. Almost a century later, the discussion continues, and Schrödinger's cat remains one of the most famous examples of quantum weirdness. When I first learned about this, I couldn't stop imagining what it would feel like to open the box. Would I hesitate? Would I feel nervous? In my imagination, I was the one deciding the cat's fate. Physics suddenly felt alive. It wasn't just numbers and equations. It was a story about uncertainty, observation, and possibility. To make it more relatable, consider flipping a coin but keeping it covered. Until you look, it is neither just heads nor tails. In a sense, it is both. Or think about waiting for a message on your phone. Until you check, you are both informed and uninformed. Schrödinger's cat makes this abstract idea tangible. Superposition is central to quantum physics. Electrons, for example, don't spin clockwise or counterclockwise until measured. They exist in a mixture of both states. It is as if the universe itself is undecided until observed. Once observed, the state collapses into a single outcome. This leads to the observer effect. By opening the box, we force the universe to choose alive or dead. Observation affects reality itself. This concept fascinates me because it shows that humans are not passive observers. We are participants. Some interpretations suggest consciousness itself collapses the wave function. Others, like the many worlds interpretation, propose that both outcomes happen simultaneously in parallel universes. In one universe, the cat is alive. In another, it is dead. We simply experience one branch. Thinking about this challenges how we understand reality, existence, and our role in the cosmos. Quantum mechanics is not merely philosophical, it is the foundation of modern technology. Transistors rely on quantum tunneling, lasers work because of quantum principles, and MRI machines depend on quantum spin. Emerging quantum computers rely on qubits in superposition to perform calculations impossible for classical computers. Understanding that these mind-bending principles are both real and practical deepened my respect for physics. Schrödinger's cat is not just a story, it is reality. The history of quantum mechanics is fascinating. Max Planck, who introduced the idea of quantized energy, started a revolution. Niels Bohr developed the model of electrons in discrete orbits. Albert Einstein challenged the idea of randomness, calling it spooky action at a distance. Schrödinger and Heisenberg extended these concepts, leading to debates about determinism, reality, and measurement. Physics is not just about learning facts, it is about pushing the boundaries of human understanding. Experiments like the double-slit experiment reveal the heart of quantum strangeness. Particles can behave as waves, creating interference patterns. When observed, they behave as particles. Observation directly affects outcomes. Other phenomena like quantum entanglement show that particles separated by vast distances can influence each other instantly. These concepts sound almost magical, but they are verified experimentally. They show that reality is stranger than it seems. I love physics because it challenges me to think beyond common sense. Schrödinger's cat made me imagine possibilities I had never considered. Reality can exist in uncertainty until observed. That idea ignited my imagination. Physics combines logic and creativity. To understand quantum mechanics, I need math and reasoning, but also imagination. I visualize cats in boxes, particles acting like waves, and universes splitting with every measurement. This mix keeps me curious and motivated. Sometimes, studying physics feels like solving a puzzle left by the universe. Even when problems are difficult, the process of thinking is satisfying. The deeper I explore, the more elegance I find in the natural laws. Stars, light, water molecules, sound, all follow rules physics can explain. Discovering these patterns feels like uncovering the secret language of the universe. Physics also inspires reflection. It forces me to ask questions about reality, perception, and existence. What is real if observation changes outcomes? How much does consciousness shape the universe? Schrödinger's cat is not just a cat. It is a gateway to philosophical questions, imagination, and understanding our place in the cosmos. I also find that physics connects the very small to the very large. Quantum rules explain atoms, molecules, and particles, but they also underpin stars, black holes, and the evolution of galaxies. Everything is connected, from the behavior of electrons to the fate of the universe. Physics gives me a sense of connection to the world and to something much greater than myself. In daily life, physics is everywhere. The way light reflects, how sound travels, how energy flows, all of it follows principles I can study and understand. Even mundane tasks like boiling water or using a microwave reveal quantum and thermodynamic phenomena. This constant presence of physics in life makes it feel like a living, breathing science that I can interact with every day. In the end, Schrödinger's cat represents curiosity, mystery, and the strange nature of reality. It embodies everything I love about physics, the ability to surprise, to challenge, and to completely change the way I see the world. Physics teaches me to ask better questions, imagine possibilities, and keep exploring. That is why I love physics. It doesn't just give answers, it gives wonder. And I will never stop learning, imagining, and asking questions, even about cats in boxes.